Hey guys, the objective for this video is to discuss conservation of mass, momentum, and energy. So when looking at the conservation of mass, the mass input is equal to the mass output plus the amount of mass that accumulates within our volume. So each of these terms here is equal to the change in the mass, and the change in the mass has to be equal to 0. So this term here is the change in density with respect to time. So that may be caused by changing pressures in our fluid, which may cause it to change density. And then when you take density and you multiply by volume, you obviously get mass. So this is mass with respect to time. We've got this integral here because we've got that changing density here. Density is not constant and changes with time. And then when we look at this second term here, we're looking at a surface. So the surface of our volume. We're considering the mass of the fluid going inwards or outwards. So this here, we're looking at the velocity vector and the normal vector. So we're taking the velocity that's going normal into or outwards from our surface. Velocity, we're looking at distance over time, and then the distance times the surface is going to give us some form of volume, and the volume then times the density gives us that mass. And then we still got that change in time term from the velocity. So again, we're getting the change in mass with respect to time. And that change in mass with respect to time has to be equal to 0. Now, from the conservation of mass equation, we can derive the conservation of momentum equation. Momentum is just mass multiplied by velocity. So the change in momentum is actually transferred as a force.